Welcome to the session. This is about understanding broker or load balance. And my name is Hee-Sung Son. Thank you for the introduction. And I'm a platform engineer at Stream Native, based in San Francisco Bay Area. I joined Stream Native in April this year, and I'm currently focusing on the broker load balance component. Previously, I worked at Aurora MySQL serverless team, specifically I was involved in serverless version 2 feature at AWS. And here is my LinkedIn profile. And this talk is actually based on our recent tech review about achieving broker load balance. And then hopefully this further helps to understand how the broker load balance works. So let's get started. Here is the agenda today. First, we will recap how the load balance or the load balancing works in distributed messaging in the Pulsar context, including topic bundles. And we'll dive deep into individual auto bundle load balance logics. And then we'll talk about operation tips. Then we can wrap up the session with our work and then the Q&As. So first, let's recap how the message load flows into distributed messaging and streaming systems. Here are the important facts. First, messages are grouped under the topics. As you can see, the messages are under the topic. Second, message pops up for a topic is served by a single broker. This means a topic is not served by different brokers. So then if you step back and see this picture, in fact, topics or groups of topics are considered as a good load balancing entity. In short, for our definition, I think load balance can refer to efficiently distributing topic messages across the brokers. On the other end, in Pulsar has unique architecture where serving layer and the persistent layer are separated. Then, as you can see, at the serving layer, brokers serve topics, pops up sessions, and then brokers read write messages and bookies in the persistent layer. This means broker load balancing refers to efficiently distributing topics serving sessions across the brokers. So in this talk, we will mainly discussing about the broker level topic session distributions. Then the question is how to make it efficient, or how does the Pulsar make the broker load balance efficient? Let's talk about it. The idea is very simple, I think, and very intuitive. Why not making the topic balancing dynamic? We'd like to assign topics to underloaded brokers when there is no owner, and then unload topics from overloaded brokers whenever we see high CPU and high memory and high network IOs. Then someone might ask, is it possible? Is dynamic unloading possible without harming the performance? The answer is yes. Thanks to the serving and persistent layer separation, Pulsar can seamlessly transfer rebalanced topic sessions across the brokers. Unlike other monolithic systems, in Pulsar, topic broker assignments are flexible as the messages are not stored in the Pulsar broker's local disk. This means Pulsar brokers are somewhat stateless in terms of message store. Then after the dynamic unloading, the new owner brokers can simply reestablish connections to the clients with the minimal client jitters, connection jitters. This means new owner brokers can simply look up the bookie metadata to locate the bookies where the messages are stored. Then what about the bookie load balancing? To complete our context in the both layers, both serving and then persistent layers, let's recap how the bookie load balancing works here. One important concept is messaging segmentation. In fact, topic messages are segmented, replicated, distributed to the multiple bookies. Let's take an example here. Here, the topic 1 is currently served by the broker 2. And it has messages segmented to the X number of segments, and is replicated twice, and then distributed to the 4 different bookies. This means the message load from the topic 1 is now distributed to the 4 different bookies. Let's say we want to add more disk space for the topic 1, and we want to add more bookies, X and Y. Then the new segment, new message load, X plus 1, X plus 2, are now ramping up on the new bookies. One important point here is that the existing segments, message segments, do not transfer to the new bookies. This means Pulsar does not require data rebalance while horizontally scaling. So this talk is mainly about the broker level load balance. And for those of you who are interested in the bookie level architecture and how the messaging flows, then you can refer to, I think, this article. I think this article really explains well about the bookie layers. Now let's talk about topic bundles. One of the important concepts about the broker load balance is that topics are balanced to brokers at the bundle level. This means topics are grouped into bundles, and the bundles are actually distributed to each brokers as a broker load balance unit. And then someone might ask why we need this middle layer group bundles. With the multi-tenancy in its nature, Pulsar requires to scale for a large number of topics. In the worst case, probably the millions, thousands of topics. The problem is then that there could be a lot of metadata stored to store those topic, the millions of topic level metadata. The solution is why not sharding the topics. The initial number of bundles and then the max number of bundles are configurable by the following configuration. Now let's take an example to see how actually topic bundle lookup works. In Pulsar, it actually uses hash sharding. Let's take a look at this example here. So to simplify our problem, let's say the bundle key range spans 8-bit space from 0 to FF. And there are 2 bundles right now, partitioned at 80. Then let's say the topic 1, we first need to compute the hash code of topic 1. In this example, let's say it's OF, and this is the bundle key. Then now you can see that bundle key, the OF, falls into the first bundle's key range here. So now with this process, we can conveniently look up the bundle by topic. So far we covered the context about the broker load balance. And we now learn that broker load balance happens at the bundle level. So let's dive deep into individual logics and the details. There are 3 major logics in broker load balance. First, bundle broker assignment. Pulsar can automatically assign a new broker when there is no owner of a bundle. Secondly, we have a bundle unload. If some of the brokers are overloaded, then Pulsar can dynamically unload those bundles from the overloaded brokers. Lastly, we have bundle split. Let's say we have a bundle with a large hash key range, end up serving a lot of topics. Then we probably want to split that bundle into the smaller pieces so that we can distribute the topics to the more bundles and then unload to other brokers as well. Later slide, we will dive deep into the sequence, how actually individual logic works. So let's take an example here. In this example, client is trying to discover, this example is, by the way, about the bundle broker assignment. The client is now trying to discover the owner broker of the topic 3. First, it randomly connects to any brokers. In this example, it connects to the broker 1. And the broker 1 look up the bundle for the topic 3. Here in this example, bundle 2 is the mapped bundle. And then it checks the metadata store who owns the bundle right now. Right now, there is no owner. So it redirects client to ask the leader to make a new assignment. The client connects the leader. The leader identifies that, oh, the broker 2 is now green, so it should be the new owner. And then clients connect to the broker 2 with the decision information from the leader. And the broker 2 takes the ownership in the metadata store so that the other brokers can know that now the owner is the broker 2. And finally, broker 2 returns to the client that is ready to serve the traffic. We will discuss more about these 2 questions. First, so how does the leader know the broker 2 is green? Second, what's the strategy to select a broker among the available brokers? So first question, how does the leader know broker 2 is green? In fact, every broker publishes load data to the metadata store. This means the leader broker can collect the global load information from the metadata store. And there are 2 types of load data, bundle load data and broker load data. Bundle load data is just bundle level message in and out rates. Broker load data is broker level resource usages, such as CPU, memory, network, and message rate. Then with this global load information, currently in Pulsar, the leader makes all algorithmic load balance decisions. Next, we'll figure out what's the strategy to select a broker among the available brokers. Currently at the latest branch, we have 2 options. The first option is least long-term message rate, which is default. It's a lot of details and a lot of formulas, but let's go over. Hopefully it makes sense. First, it checks the max usage, resource usages. And if the max usage is below the threshold, currently the default is 85%, then it randomly selects a broker among the least long-term message rates. Let's move on to the next strategy, which is recently added. It is based on least resource usage with weighted signals. It is probably too much details, but let's see if you can understand this. First, it computes current broker's load based on the max of weighted CPU and memory and network signals. Then it computes moving average using exponential moving average equation. Then it computes the global average across the brokers. Finally, it selects a random broker among those candidates with a lower resource load than the global average. I think this formula or this equation is good to remember because it is used by other strategies in the unloading logics. Next, let's check about a bundle unload example here. In this example, publisher 1 and publisher 2 are bombarding the broker 1. So we want to unload some of the bundles from the broker 1 here. So first, leader identifies that broker 1 is overloaded from the global load data from the metadata store. Then it sends the signal to the broker 1, oh, you need to disable the bundle 2 from the broker 1. Then the broker 1 first disable the ownership in the metadata store so that the future connections for the bundles could be blocked. Then it closed the topic connections under the bundles. And then finally, it removed the ownership in the metadata store. At this point, The publisher 2 lost the connection, so it needs to reinitiate the assignment logic through the leader. And leader identifies that the broker 2 is green now, so it assigns the ownership to the broker 2. So let's talk about different strategies about this unloading sequence. There are 3 available strategies for unloading, bundle unloading. We call it shading as well. The threshold shader, I think, is widely used, and it is the default. So let's discuss about it. As you probably remember, this is similar to what we just covered in the previous slide for the bundle assignment strategy. It uses the same formula, and then the threshold shader first finds the target target brokers with the same formula, and then commands shading from the highest throughput bundles to the lowest, to enough to reduce the broker's load down to the configured threshold. These scalar parameters and the weighted signals are also configurable to fine-tune the formula here. Finally, we have a bundle split example here. Similarly, we have a publisher 1 and publisher 2 bombarding the broker 1. But at this time, these topics are mapped to a single bundle, in this example, bundle 1. So we want to split this bundle to the smaller pieces. The leader broker first identifies the bundle 1 is overloaded from the same global load data collection sequence. Then command the broker 1 to split the bundle. And the broker 1 splits the bundle 1 to the two child bundles. And then initially takes the ownership of these 2 child bundles in the metadata store. Then optionally, broker 1 can unload those child bundles. And this optional unload can be configurable, and by default is enabled. Let's talk about different strategies for the splitting as well. There are 2 parts to cover bundle split strategies: when to split and how to split. Regarding the when to split, Pulsar uses threshold-based strategies. So whenever the bundles metric is beyond this threshold, the Pulsar trying to split those bundles. And Pulsar currently supports the following thresholds: bundle max topic counts, max sessions, and max message rates, and max network load. Regarding how to split, Pulsar has 2 strategies: equal range split and an equal topic count strategy. The first one basically splits the bundle to the 2 parts with the same hash range size. Second, it splits parts with the same topic counts. It is also configurable, and by default, Pulsar uses equal range split. Let's take an example how the bundle equal range split works here. Here, we want to split bundle at 40 because that's the middle point. And as you can see, now the topic 2 is mapped to the second bundle after the split. So I think that's a great point to stop, pause. That's pretty much about all the load balance logics. I think that should be, I guess, a good summary here. And I guess we can talk about operational tips in the next slides. First, I'd like to introduce available load balance signals in the Prometheus. The first part are the input load balance signals such as CPU and memory and network. And these are scaled in 100%. The next ones are the outcome of the load balance. The blue one is about the bundle split counts, so how many split happened. The purple one is about the bundle unload counts. And then brown one is about bundle assignments or the topic assignments counts. So using these metrics, I think we can create a Grafana dashboard like the example here. So we can track the load balance signals and the state of load balance outcomes. Next, let's take some examples of the configurations, how to set the default bundle counts. There are two ways to configure the initial number of bundles. First, we can use the default number of namespace bundle configuration in the broker config. Also, we can pass the specific bundle count in the namespace creation command. Remember that the split strategies can be also configurable in the broker configuration file. Then someone might ask, so what's the good number for bundle count? I think any bundle counts bigger than brokers could be a good start, in my opinion. So for example, 1,000 we have a namespace with 1,000 topics and 16 brokers. Then 16 bundles could be a good start, which is 4 times more than the brokers. Let's check more commands to identify any bundle states. First one is how to list the bundles in the namespace. Here we can pass a namespace, and it outputs the number of bundles and the bundle ranges for a specific namespace. And also we can check the list of topics in a specific bundle. Here we pass the specific bundle range here, and it prints out the list of topics. Also we can look up the specific bundles by the topic to identify which bundle is serving the topic I'm interested in. Also, we can look up the owner broker of topic to identify which broker is serving the topic I'm interested in. Let's talk about some edge cases here. So for some reason, broker load balancer doesn't work as it's supposed to, then probably our operators need to run some manual operations like manual bundle split, manual unload. For this purpose, Pulsar supports the following commands. And this unload operation or split operations are relatively safe to run because those unloaded bundles could be reloaded to the available brokers, though there could be some minimal client jitters. Then first, we have to identify which broker or which bundle is overloaded to run those operations. I think that this command is useful, broker state load reports. Along with broker level load informations, it actually prints individual bundles load information so that we can identify which bundle is currently overloaded. So information such as message rate, message throughput, consumer count, producer count, and topic counts. So I think this can be pretty useful to identify which bundle is overloaded right now. With this target bundles to identify, we can run the following command to actually run split and unload operations. First, we can manually split and unload the bundles in the namespace with this command. So this command, we specify the bundle range. And also, we specified bundle split strategies. In this example, we use equal range split. And also, we pass this unload command option -u after split. So this command will equally split this bundle and also unload those bundles from the current owner brokers. Next example, it splits and unloads the largest bundles with the same options. But at this time, we use different strategies. Here, it uses a equal topic count strategy. And as you can see, the bundle option is the largest. We didn't specify the bundle range here. Third, we can also specifically choose a bundle and then unload it without splits. And also we can unload, this is intrusive operation. We can unload every bundle in the namespace. So every bundles will be basically unloaded to other workers. Let's talk about our current work and future work. So we want to improve the feasibility of the broker load balance. And for one of those efforts, we are adding more logs. So these are PR we raised. And also we have a new PIP project, broker load balance improvement with a new implementation. The goal is we want to make a load balance more efficient and also operational. One key idea for this project is currently broker load balancer heavily relies on Zookeeper for its metadata store, load data metadata store, such as load data and ownership data. This project, we want to get away from Zookeeper and instead rely on Pulsar topics so that the project can align with our long-term project, Zookeeper-less Pulsar. We have a Slack channel, so please join if you are interested in this project.